Hello everyone. Hi, am I audible and visible to you all? Please just confirm, and I'm able to see your chat, and I hope I'm absolutely clear to you all and completely visible and audible. Please let me know. And simultaneously, I just want to make it clear that what we are going to discuss right now. I hope you all are aware about this wonderful test series AIATS plus 2025 phase 2. Why phase 2? Because phase 1 has already been conducted, and in this series, this is plus series for personalized learning for ultimate success. So those who are the participant, they already know, and for others who have just joined, I just make them clear that we will be discussing a mock test here. With respect to that, we'll be talking about some of the topics which are important, and I'm not able to see the chats here, so please write me here in between also while I'm discussing the question, and if you find that any question or the query you are facing, you can just ask me here in the chat section, right everyone? So shall I begin with this? This was the examination, this was the mock test 5B, and it was conducted on 16th of February 2025 definitely. And if I'm just talking about the sessions since the morning, number of concepts you learnt so far, and turn is to deal with some more concepts which include from the class 11, the first chapter, that is basic concepts of chemistry, then we have the structure of atom, then periodic classification and the chemical bonding, and simultaneously one of the chapter from the class 12, that is chemical kinetics. So those topics, those chapters I'm going to take here, and the questions based on that which were there in this mock test. This mock test is entirely aligned with the NEET paper, right? So I just ask you to keep practicing the questions simultaneously. Those who are the partners of the series, those who have opted for the series are going to get this. They already got this, but when I'm talking about others who joined the session, should also practice the question, and you will find that these are very, very helpful. Simultaneously, I'll be taking 1 or 2 questions from the previous year paper as well. Okay. So good afternoon everyone, and let me begin with the question. That's a question number 46 of this paper. So that numbering which is aligned with the paper, which is here, right? The question is the extent of overlapping. So pen is already with me. Extent of overlapping of atomic orbitals from the same shell is in the order. Very good afternoon all of you. Very good afternoon everyone, and what we are doing right now, we are doing this AIATS plus phase 2 question paper number 5B we are discussing, where the first question is based on the extent of overlapping of atomic orbital. So I hope everybody is aware. Good afternoon everyone. Good afternoon everyone. So when I'm talking about the extent of overlapping, the question is from the chemical bonding for sure, how the atomic orbital get combined. So what is the pattern? The pattern is overlapping, right? Now if I'm talking about overlapping, you can simply say that overlapping is overlapping of atomic orbitals, which we are talking here. This is basically the interpenetration. Interpenetration of atomic orbital, right? And what actually happened after that? After that, the electron clouds which are present there in the atomic orbital, they get shared and they become common for both the atomic orbital which are taking part in overlapping, right? This is the simple thing that you need to consider. Namaste, namaste, and good morning, good afternoon, all the best wishes to you all. Okay, so electron clouds which are present there in the atomic orbital, they get interpenetrated, and the electron cloud which was separately belonging to the different orbitals, now it's common, right? Now question comes, what happens with the help of that? Definitely when atomic orbital overlap, then there is the formation of the chemical bond. How? The two atomic orbital, like suppose I'm talking about hydrogen molecule. Two hydrogen atoms come in contact and their two orbital, one is from one hydrogen atom, one is from other hydrogen atom, they get overlap, right? And that overlapping results in the bond formation, right? Energy lowers, and at the lowest most point there is the formation of bond there, right? So this is the way how overlapping occur. Very good afternoon. So the question was, the extent of overlapping of the atomic orbital from the same shell is in the order. So now if I'm just looking at the question, you have the options in which you have p overlapping. The two p orbitals came in contact and they overlapped, right? So this is sigma overlapping, single bond is formed. Same ways for sp, there is the overlapping, and then ss overlapping, right? Now if I'm talking about ss overlapping, we have the 2s orbital, they overlap, right? And their electron cloud just get combined, and you know the electron which is present in both of these atomic orbitals now get paired and they will also align with the opposite spin. That had happened, right? But one answer is one given by Dorado, right? Very good, very good. So I'll be coming to the answer, but now sp overlapping, s and one p orbital, they overlap this way, and after overlapping, this is sp, right? So electron cloud gets shared, and later when you study the concept of hybridization, there also you understood that how orbitals get hybridized, right? Post overlapping, right? The same way is pp overlapping, so head-on overlap would be there, right? Now the question comes, there are different type of overlapping. There is positive, negative and zero overlap. Positive overlap, that when the presence of electron at the same side, right? So we can just simply write here, this is representing the positive overlap. And suppose in the similar case you have s orbital with the electron, and here the two lobes of the p orbital, and this type of overlap you find, this is termed as the negative overlap. So this type of question also you can find in the NEET mock test and even in the NEET paper, that which of the following is showing the positive overlap, which of the following showing the negative overlap, or even the zero overlap. In case of zero overlap, what will happen? Suppose we have the two positive, two p orbitals, but they didn't align with each other. There is the possibility of zero overlap as well, right? So this is all about the general things, those you should know. Now the question comes that extent of overlapping you need to identify. So in all these cases, there is the head-on overlap, sigma bond would be formed, but in case of ss overlap, there is the non-directional overlap, right? Non-directional. When I'm talking about pp, this is directional overlap, and that leads to the more overlapping as compared to sp or ss. So highest, definitely El Dorado, you wrote here that option 1 is correct, right? So in option 1, just have a look on this sign. It indicates that ss has the highest one, so that is not correct, right? El Dorado, I'm sorry, initially I didn't even see this mark, and hope आपने भी नहीं देखा था. चलिए, option 4 ही तो correct answer होगा. The option 4 is the right answer, where pp is representing the highest extent of overlapping, because in this case the directional overlap is there, right? Okay, Anjali, you are also right, absolutely right. So pp having the highest overlap, then ps, then ss, right? So El Dorado, now you identified that you were wrong. That is more important for all of you. Ma'am, it should not be actually 1. Why it should be 3? It should not be 3, beta. It should not be 3. It should be 4th one. Bikram, okay? So right answer we got, and the turn comes for moving towards the next question, right? So Bikram, you have to check, 3rd is not the right answer. The correct answer is option 4. Okay, beta? Now, there is the turn for the next question. The question is, question number 47, the outer electronic configuration of the inner transition elements is. So question is from the chapter 3 of class 11th, periodic classification of elements, right? Periodicity in property is also there. So when I'm talking about the inner transition element, what type of element these are? Which elements are termed as inner transition elements? F block elements. F block elements are considered as what? Inner transition element. And what about transition elements? I hope everybody is aware of NEET is very close. So you should know this is the simplest thing that you have already studied. So D block elements are transition elements, right? And if I'm talking about, yes, right, Bikram. P block elements, if you just talk to different groups, have their different names with respect to their first element. Suppose I'm talking about the group 13, the boron family, group 14, carbon family, group 15 is known as nitrogen as well, nitrogen family. Then we have group 16, chalcogens, oxygen family, and then halogens we have, and further the noble gases. So P block is the elements which are present there are very versatile, different natures they have, metal, non-metal, metalloid, everything is present there, right, Bikram? Yeah, answer for the question is option 4 that I need to look at, okay? I'll be just checking. So, we were talking about F block elements, and if it comes that you need to identify the outer electronic configuration, so we have to look at the option. So NS2, this is just representing an S block element, and more specifically group 2, right? So this could not be my right answer. Now when I'm talking about the next one where NS2 NP1, so last electron is entering in the P orbital, right? So this is representing P block element, okay? Now when I'm talking about the next one, here it seems this is the anti-penultimate shell N-2, anti-penultimate shell, N-1, penultimate shell, and N is the valence shell, everybody is aware about it, right? So in the anti-penultimate shell, electrons are entering from 1 to 14, okay? And here in the d orbital 1 to 10, so there is a problem. This is correct, but this is incorrect with respect to the outer electronic configuration of F block element. So that can make you confused. Don't be confused. The actual configuration is N-2, F 1 to 14 electron there would be. Boron family NS2 NP1, right beta? So N-1, D 0 to 1, and then NS2 in the valence shell. So fourth one is representing absolutely correct electronic configuration, and more specifically the outer electronic configuration for the inner transition elements or the F block element. Got it? Right? So simple question, and from the third chapter you will find such type of question there, like the configuration, like representative element you need to identify, same ways the transuranium element, so some certain terminology is important. Same ways the nomenclature of the elements with the atomic number more than 100, that is also important. IUPAC nomenclature, like for 101 the name should be nil, anium, right? But the IUPAC official names are also provided to those elements, that also you need to remember, right? And same ways as you move forward in the third chapter, you will find that there are the physical and the chemical properties of the element with respect to their respective groups, right? And even in the period how the variation occur, so gradation in the property, what you observe, even how the certain property increases or decreases, that you need to know with respect to the each of the group or the each of the family, right? And suppose I'm talking about the characteristics which are important, which are given there in NCERT. So there is the atomic size, ionic size, about that the question generally asked, and same ways for electron gain enthalpy, electronegativity, the metallic behavior, right? So that you need to understand. Even the oxidation state of the element. So beginning of the oxidation state occurs there, not specifically in the redox. Before redox, in third chapter, we talked about oxidation state. So the chapter is important. And yes, so what study empire, F block and D block. Yes, F block and D block, their configuration, their initial information that you will find from there, and later you will study in detail in D and F block, and then in coordination compound also the compounds from the d orbital and their coordination complexes we study. Okay, so we found the answer. Turn comes for the next question. Question number 49 we have here. So this question is from the chapter chemical bonding and the molecular structure, and this is this type of question where the molecular orbital configuration we need to look at. That we need to just whenever I am talking about such type of questions, so molecular orbital theory comes, and this is the favorite type of question from the paper setters at NTA. They will ask you the question that what will happen if it is changing from this and where the electron is entering. What will happen to the bond order? That question can also be asked. So let's focus on this question, then we'll move for different concept which could be asked from this question. Done? Okay. So during conversion from O2 minus to O2 2 minus. So in this case, what is actually happening? You are adding one electron. Though it's a very difficult process because oxygen already has the negative charge and you are adding one electron to it. Highly energetic process it is. Everybody is aware about it, right? And if electron you are adding to it, in which orbital it is adding, right? That you need to identify. So first of all, we have to just think about the molecular orbital configuration for this O2. Okay, so I hope you know that how it's been filled. Sigma 1s2 bonding orbital, then sigma anti-bonding 1s, so 2 electron here. Simultaneously I am filling the electron as well. 2s2, sigma 2s2, sigma anti-bonding 2s2. So this is the common configuration for all the elements, right? So sometimes instead of writing this, you will find even in NCERT this is written as KK, right? And then further the filling in the next one. So when I am talking about O2, in this case sigma 2pz is filled first this way. So how many electrons we filled so far? See, 10 electrons we have filled, and in case of O2 how many electrons we have? Simply O2, not about O2 negative or somewhere. Only O2 if you talk about, then 16 electrons needs to be filled, right? So pi 2px and pi 2py with the same energy. So generally we mark this way just to represent that 14 electron, and then turn comes for pi anti-bonding 2px and pi anti-bonding 2py. This way this filling occur, and now remaining 2 electron, one each being filled. Done? So this is how we represent the electronic configuration for O2. Now I have difficulty in the question regarding bond configuration. I get confused in bond configuration before 14 and after 14. Any short trick to remember this? So in case of O2, in case of electron having after 14, as you have already written there, Bikram. So what happens after 14? First of all, you fill this sigma 2pz. This is the configuration which remains same for all of them. Any type of dimolecular species, diatomic species if you are looking at, this configuration remains same. There is no change, right? And after that, more than 14 if you are looking at, 2pz is filled first, right? And more energy is aligned with pi 2px and then pi 2py. They have the similar energy. And then turn comes for pi anti-bonding 2px and pi anti-bonding 2py. So this is how we fill more than 14, right? And when it comes to less than 14 or 14, in that case the sigma 2pz will come after pi 2px and pi 2py. So this is the only variation that you need to remember. Okay. Now in case of O2 minus, one electron is already added to this O2. So one electron I have added. I am just adding one electron to any of these, either in 2px or in 2py of the pi anti-bonding. So 2 electron I will be marking here. Done. Now you are adding one more electron to make it O2 minus. So what you need to do? You have to just add one electron in the next, because there is the possibility of the addition of electron. So what you will be doing? You are adding one electron to it. When you are adding, you are changing this O2 minus into O2 2 minus. Done? So in which orbital, in which molecular orbital I have just filled it? Just check in which orbital I have just filled. Either in pi antibonding 2px or in pi antibonding 2py, because they have the similar energy, right? So just check among the given option, pi, this is sigma antibonding 2pz, not my answer. Sigma 2pz, pi 2px. Is it the right answer? No, because the orbital in which the electron entered was pi antibonding. Pi antibonding 2p, either x or y. So why it is? This is the right answer. Option 4. So those who have already mentioned the right answer, the study empire, Lakshya, Naila, Sunetra, everyone, even Bikram, I hope your doubt is also cleared. Okay. So this is how we fill. Now the question comes, what more could be asked from this? So in this case, they can ask you to calculate the bond order. How to calculate bond order? Can anybody tell me here? Can anybody just let me know that how to calculate bond order? The simplest formula that you have already studied, I hope. Bond order is half of the electron in the bonding MO. The electron in bonding molecular orbital, the electron present in it, minus anti-bonding molecular orbital where the electrons are present. Done? This is how we calculate. Okay, suppose anybody asks you to find out the bond order of O2. So in case of O2, we can leave this. These are equal number of electron in bonding and anti-bonding MO. We can leave, but later we need to just look at that how many electrons are there in bonding, how many electrons are there in anti-bonding. That ways you can move. Right, Bikram? Very good. So there also in case of oxygen, in total if we count, then total 10 electrons are there in bonding molecular orbital, and in anti-bonding there are 6. Right? Just check. If it was O2, then there was 1 electron here, 1 here, 2 electron this way, and 4, 6. So that 6 I marked. 10 minus 6, and this is 2, the bond order. Same ways, if you are calculating for O2 minus, it means you are increasing 1 electron in anti-bonding molecular orbital. So in that case, 10 minus 7 you will be doing. In case of O2 2 minus, what needs to be done? In case of O2 2 minus, 10 minus 8 needs to be done. Why 8? Because in the anti-bonding molecular orbital, you have increased 2 electrons. Right? You are comparing with O2. And in O2 2 negative, 2 more electron you have entered, you have allowed to enter in pi anti-bonding MO. So that makes 10 minus 8. So bond order becomes 1 that case. Clear? Okay. So from the molecular orbital theory, this type of question, calculation of bond order, simultaneously they can just ask you the stability of the species. Do remember, higher the bond order, higher would be the stability. So there can be a statement type of question that they can simply write that O2 minus 2, O2 2 minus. What happens to the stability? In that case, if they are saying that stability increases, it means the answer is wrong. The statement is wrong. Because in case of O2 negative, in pi antibonding molecular orbital, the number of electrons are less. While in case of O2 2 negative, you are allowing 1 more electron. In the pi antibonding MO, more the number of electron in antibonding MO will decrease the stability. Right, lesser the bond length. Yeah, higher the bond order, less would be the bond length. Right, Vikram? Okay, so in this continuation, we can simply write that higher the bond order, higher would be the stability, less would be the bond length. Okay, Bikram, I also added your point that you have mentioned there. Right? Okay. So, study empire said that stability decreases. Right, very good. If you are changing O2 minus into O2 2 minus and you are allowing 1 electron more in anti-bonding molecular orbital, that's why stability decreases. Okay? So, that you need to look at while you are writing the molecular orbital configuration. With the help of that, you can even identify the stability, even the bond length also. If you know the, in this case also, as stability decreases, you can simply say the bond length increases with this simple relationship. So here we are not talking about the data, we are talking about what happens when electron is entering in a particular molecular orbital. Okay? Right, everyone? Shall I move forward? Okay. So now another question. I hope this is visible to you all. The chapter structure of atom. from which this question's been taken. Okay, and now I have to change the color of my pen as well, because on the white I'll be writing from the black pen, right? So match the following list 1 and 2, and you need to identify the color combination. So in the list 1, you have quantum numbers, and antibonding electron is added to, no, electron is added to the pi antibonding molecular orbital beta. Okay? Yes. So quantum number and here the information provided. So I hope you know that for an electron, the complete address of an electron in an atom, we identify with the help of quantum numbers. Address of electron means what would be the size and the energy of the shell, what would be the shape of orbital in which electron has the maximum finding probability. I hope you know that orbital is the space in 3D in which finding probability of an electron is maximum. Okay, so that information we can get from there. So azimuthal quantum number, suppose you are talking, that tells us about the shape of orbital. Principal quantum number tells us about the initial address. It means the shape and the size, not shape, size and the energy of the shell, right? Further, the magnetic orbital quantum number is given. So when I'm talking about the magnetic quantum number, so that tells us about the number of orbital which are present in a subshell, right? And further, the spin of the electron in that orbital. Okay, so someone there is don't talk. Don't talk while I'm preparing, right? Okay, so option 3, that I need to check. So what I'll be telling you here, that principal quantum number that we represent with the help of the alphabet N. This is principal quantum number. It tells us about energy and the size of shell. Even the number of electron in a particular shell is also given by it, because the number of electron in a shell is calculated by the simple formula 2n square. Done? Now further we have L value, that is azimuthal quantum number, right? Azimuthal quantum number represented by the symbol L, okay? And this tells us about the orbitals. Suppose L value is 0, right? It represents S orbital, spherical shape, right? Now same ways for 1, the dumbbell shape of the p orbital that comes to the mind. So these are the subshells. Then further we have second one, d orbital or the d subshell, because in the subshell there are orbital further. Further we have f orbital or f subshell. Now in S subshell, if I'm talking, instead of writing orbital, it would be better if I'm writing subshell here. Let me rewrite it. Subshell. And with respect to this, we can find out the orbital as well. So S subshell we have, then S orbital, 1 S orbital it would have, right? Same ways. So this is the information that we are getting from the quantum numbers. So if p orbital we have, there would be 3 p orbitals, and these p orbitals are px, py, pz with respect to the coordinate axis. Okay. Same ways for d subshell, if we are talking, 5 d orbitals we have. Okay, and those are dxy, dyz, dzx, and dx square minus y square and dz square. I hope you have studied them. Their shapes are also important. There can be a question with respect to the alignment with respect to the coordinate axis. So that you need to also revise. Okay. Now further, here the 7 f orbitals which are present there in f subshell. Done. Now the next thing, if you know the value of n, then what are the possible values of L? That can also be calculated. So for a given value of n, the L value would be 0 to n minus 1, right? There can be an electron in an orbital is given. Suppose you will be given as 3d1 electron, and they can ask you all 4 quantum numbers. For the 3d1, if you're talking 3d1, so this is n value. What is the d value here? I mean, d orbital is given. What would be the L value? See, 2 it is L value, right? Now m value, or the magnetic quantum number with respect to L, from minus L to plus L, right? So the possible values for m would be, see, n is equals to 3 in this case, L is equals to 2, and m would be minus 2, minus 1, 0, plus 1, plus 2, right? And what about the spin quantum number? The only possible 2 values are there, plus half or minus half, clockwise or anti-clockwise. That is it, right? Now spin quantum number tells us about the spinning of the electron, whether it is clockwise or anti-clockwise. So this is all information with respect to the quantum numbers I have provided here. Now let's match. Okay, principal quantum number, the size of orbital, energy होता तो energy भी हो सकता था, right? Azimuthal quantum number, so spin quantum number I am matching with the first one, सबसे ऊपर दिख रहा है. So this spin quantum number I have matched with the first one. Then azimuthal quantum number, shape of orbital, and further magnetic orbital quantum number gives us the number of orbitals in a subshell, right? So if I am matching it, then A is matching with the fourth one, then B is matching with the third one, C is matching with the second one, and D is matching with the first one. So third option is the right answer for this question, right? Okay, now I'm moving forward with the next question, and the question is from the chapter chemical kinetics, right? And in chemical kinetics we have the question which is based on the rate or the kinetics of the first order reaction, I should say. Okay, 75% of a first order reaction is completed in 30 minutes. The time required for the completion of 93.75% of the reaction in minutes is. So first thing which is given here is T 75%. Completion of reaction, you have to just find out the completion of 93.75%, and completion of 75% of the reaction is given. The time taken in this process is 30 minutes, right? Now what is the formula for the calculation of K for the first order reaction? The simple formula I hope you know, that 2.303 by T log R naught, that initial concentration of the reactant, upon the remaining amount after T time. Okay, and this can also be represented as, suppose time needs to be calculated, then K will come here. Now in the first case you have 75% been completed, and for the same the time consumed is also given. So what I can do, I can first of all calculate the value of K. Value of K with respect to the first hint that is given, right? So it would be 2.303 divided by 30, right? Then log R naught. So initially, because 75% been completed, so what I'm going to take, that initially it was 100, 75% completed. So how much is remaining? 25, right? So you can calculate this way. Else, one more thing you can do. See, 75% completion. It means, first of all, it completes 50%, right? And if 50% is completed, then how much amount is left? 50% left, right or not? 50% left. Now from this 50%, if 50% more is reduced. Then how much is left? 25% is left. 25% is left. So why not you can say that here this process in which 100 is getting changed into 50, that takes 1 half-life. This is 1 half-life. What is half-life? Yes, Bikram, absolutely right. K would be same for both the reaction. You can simply equate them, right? But here one more thing I am telling you. If I am talking about 75% completion, that means we are utilizing 2 half-life, isn't it? Just check. Just check. In the first half-life, from 100 to 50 you have changed. Right, Bikram? From 100 to 50 in the first half-life. And in the second half-life, you have converted 50 to 25. It means 75% completion. Right? So, there are the 2 half-lives which are involved in it. It means 2 half-lives. Half-life means the time in which half of the amount of the reactant get consumed. That is termed as the half-life. Right? So, in the first case, from 100 to 50, the first half-life, and from 50 to 25, it means 75% completion. That take the 2 half-life in this process. And this 2 half-life is what? 30 minutes. This is another way to look at the question. Okay. So, half-life for this case would be 30 by 2 or simply the 15 minutes. So, this you can just identify just reading the statement. Okay, this I have just mentioned here because I just want you to understand it. Okay, otherwise by just looking at the statement you can identify that 75% means 2 half-life, and 2 half-life it means 1 half-life would be 15 minutes. If you know the half-life, what is the relation between K and half-life? K is equals to 0.693. If you know this relation, then easily you can calculate K value within seconds. You got K. Sunetra, option 3. I have to just look at. Right now, I am not going to tell you. Okay. So, K is 0.693 upon 15. And if we know the K value, either you can do this way or you can directly go with the K value by simple calculation. K is 0.693 by 15. That's it. Now, what I am going to do, I just want to find out the time for 93.75% completion. So, what I am going to do? I am going to place the values only. K value is 0.693, 15 will go there in the numerator, log R naught is 100 upon R value is 93.75. So, how much is remaining? 100 minus 93.5. 93.75, not 93.5. So, this is 6.25, right? So, what I am going to do, 2 zeros will increase here, 625, 25 fours are 400 and 25 here. So, this will cut 16, log 16 it would be. Now, 2.303 upon 0.693, simple calculation it is, 15 and log 16 means 2 raised to the power 4. Can I write this way? 2 raised to the power 4, and this 4 will come here in the multiplication. This way. Done? So, now just check this log 2 value, everybody is aware about it. What is the value of log 2? 0.3010, 0.3 I am taking, rounding off. And now, this 0.3 when multiplied to 2.303, let's multiply. 3 3s are 9, 0, 9 and 3 2s are 6. 0.6909 divided by 0.693. Approximation I did because instead of 0.3010 I have taken 0.3. So, approximately the similar value we will get into 15 into 4, 60, right? This will cut this way. It comes 60 minutes. You can calculate this way. Yes, beta. Absolutely right, Vikram. 6.25, 60 minutes. Yes, for the completion of 93.75%, we want 60 minutes, right? And 60 minutes is written here in the third option. And who said third option is the right answer? Sunetra, you are absolutely right. Sunetra, if you attempted that question correctly, you are absolutely right here, okay? And keep practicing more and more such type of questions. So such type of questions are very common with respect to the NEET examination, okay? Let me move forward with the next question. And this is the question which is sum of the properties of the two species XeO3 and BF3. So as I'm just looking at these two compounds, one thing is clear in my mind that we are talking about chemical bonding and molecular structure, okay? So which one of them is correct? Now if I'm looking at the given option, they are talking about dissimilar hybridization of the central atom, isostructural hybridization. So what I identified so far that we are talking about the two things, structure and hybridization. Fast करिए, बहुत time लग रहा है. सुनील, I was just explaining and fast ही करते हैं. So I am covering the questions from the chapter Chemical Kinetics and basic concepts of chemistry, periodic classification, as well as the chemical bonding I have already told you, structure of atom as well. ठीक है? चलो सुनील वर्मा, जल्दी से करो, फिर आप आंसर लिखो. आपने आंसर तो लिखा नहीं है. आंसर लिखेंगे तभी तो पता चलेगा आप जल्दी कर रहे हैं और फास्ट नहीं हो रहा है. आंसर तो लिखना पड़ेगा. Now the question was about XeO3 and BF3, right? The two compounds we have, xenon trioxide here is given. What type of structure it has? So where the 3 sigma bonds, right? The structure for this I have just drawn. Trigonal pyramidal structure it has. Let me redraw. 3 oxygen atoms are bonded this way. The pyramidal structure, 1 lone pair we have here this way. Okay? And same ways, BF3, trigonal planar structure it has, right? So the question was dissimilar in hybridization, definitely, because if I'm just looking at the hybridization, just check the sigma bond plus lone pair, 4 it is, right? Ma'am, Hindi explain kijiye. So when and where needed, I'll be taking beta. Trigonal planar, very good Vikram. Option 1 as XeO3 is tetrahedral, not tetrahedral, pyramidal, because one of the lone pair is present here. See, one of the lone pair. So pyramidal structure it has, right? So hybridization is different, sp3, and if I'm talking about here the sp2 hybridization, shape is also not similar. So dissimilar in hybridization for the central atom, yes, it is right. Further, isostructural with different hybridization, no, these are not isostructural. Isostructural with same hybridization, no, absolutely no. Similar in hybridization, once again, no. So right answer is option 1 for this question, right? Now I'll be taking next question. So the question number 81 we have. Question so it has the 2 statements with us. First statement says, molecular formula represent the simplest whole number ratio of the various atoms present in a compound. So when I'm talking about the molecular formula, that would have the ratio of the atoms present in the compound, definitely, but not the simplest whole number formula. The simplest whole number formula is explained by empirical formula. I hope you have studied this as well. Empirical formula explains gives the simplest whole number ratio. Okay? The statement 2 says empirical formula shows the exact number of the different type of atoms present in the molecule of a compound. So actually what happened, these two definitions, these two formats are interchanged. The first statement is representing empirical formula instead of molecular formula. It should be empirical. And the second one here, empirical is written. It should be molecular formula. So while reading the question, don't be in hurry. You have to read it clearly and carefully. Then only you will proceed. Okay? And you'll get the right answer. So both the statements are definitely incorrect. These are not correct. Okay. And in the continuation of this, I have just taken one question from the, both are incorrect because both the statements ulte likhe hai. Yes, these are interchanged, right? The definition of molecular formula is written in empirical formula's definition is written in molecular formula. Okay. I have taken a question from last year's NEET exam. In the NEET 2024, one question from the empirical formula was there, and that question I have taken here for you. Okay. So let's discuss that as well. You have a compound X. It contains 32% A, 20% of B, and the remaining percentage of C. The empirical formula of X is. So here molecular formula need not to be calculated, but the empirical formula you have to calculate. So the simple thing, you have the compound in which A, B, and C is given. The amount of A is 32%. So total mass of the compound, what I did, I have just taken as 100. So 32% means 32 gram, that amount I have taken. Okay. Now for B, it is 20%, so 20 gram. The remaining percentage of C is there. So 32 plus 20, 52, 100 minus 52 is 48. Amount of C is 48. Now, this is the mass. You need to calculate moles for the empirical formula because the molar ratio will give you the correct empirical formula. So moles of A would be its mass upon molar mass of A. So atomic mass of A is given here 64 U. So I'll be dividing it by 64 for the calculation of moles. 20 by its atomic mass is given 40 U. So I'm dividing it by 40. Then 48 upon it's 32. Right? So what would be the simple ratio? 16 2s are 32, 3 by 2. Okay. So the simple ratio that I got here is 1 by 2 is 2, 1 by 2 is 2, 3 by 2. Simplify it. So if in the denominator, this numerator, if I just multiply 2, then I'll be getting the simplest ratio. So it would become 1 is 2, 1 is 2, 3. What would be the empirical formula now? Just tell me. 1 is to 1 is to 3. So how, what would be the empirical formula now among the given options? This is A is 1, B is 1 and C is 3. A, B, C, 3, right? And this A, B, C, 3 is given here in the second option. Clear? So this is the question from the last year's NEET, and if you are attempting it right, it means plus 4 marks. Such type of question can also be there in the NEET 2025, right? Okay. So let's move forward with the next question from again from AIATS Plus program. That is question number 82 from the paper. Given below are the two statements, and statement 1 is from Heisenberg's uncertainty principle. So whatever the pronunciation you can use, Heisenberg uncertainty principle. B is the option. Let me check here. Heisenberg uncertainty principle rules out the existence of definite path, right, or the trajectories. Definitely tells us about that if microscopic particle you are talking about, then if you are able to identify its exact position, then you cannot identify its exact momentum. It means simultaneously you cannot identify the exact position and the exact momentum of subatomic particle or the microscopic particle, right? So, and it also tells us about, rules out the existence of definite path. If you know the definite path of electron, ma'am, B for the previous option. Both are incorrect, no beta. Previous question, yes, yes Bikram. You have even written the right statement. Okay, okay, I got it. So Heisenberg uncertainty principle definitely rules out for definite path and trajectory because we cannot identify the exact position, okay, and other similar particles. Now further, statement 2 says that Heisenberg uncertainty principle is significant both for the motion of microscopic and macroscopic, not for macroscopic. It's applicable for microscopic. So first statement is right, but the second statement is incorrect, right? First statement is correct, but the statement 2 is incorrect. Option 3 should be the right answer. 3 should be the right answer. What's the mathematical statement for Heisenberg uncertainty principle? That exact position that we represent by delta x and the exact momentum of a subatomic particle will always be greater than or equal to h by 4 pi, right? This is the mathematical statement for this question. Answer would be 3. Yes, Vikram. So this is the statement of Heisenberg uncertainty principle, right? And what it tells us, that product of these two would have always this value h by 4 pi. It means from the uncertainty, from exact certainty, if you are locating an electron, then its momentum would be less significant, right? So this could also be represented simply. You will find that somewhere we also represent it in terms of m delta v, and m is the constant, so I can just send it to the next side, 4 pi m, this way. So if uncertainty in position is high, then uncertainty in velocity would be low, right? So this is the relation, and this is aligned with the quantum mechanical model of an atom, okay? Now in the continuation, the turn comes for the next question, that is question number 83, and this question is further from the chapter chemical bonding, right? So chemical bonding is very important chapter and basic of other chapters of the chemistry as well. So the question is, in which of the following pairs both the species are isostructural? Isostructural means they have the same structure, the first thing, and sometimes it's been also considered that they should have the same hybridization as well. Okay, but in this question, because it's not mentioned that hybridization, we'll be looking at the structure only. So we have ammonia and PCl3. Ammonia is the central atom with the lone pair, and 3 hydrogen atoms are bonded with it. sp3 is the hybridization, right? And pyramidal is the shape. 1 electron is here. So this is the pyramidal shape, trigonal pyramidal you can say. Now what about PCl3? Phosphorus is also the element from the group 15, same nitrogen family, and it also has a lone pair in the p orbital, and PCl3, so 3 chlorine atoms are bonded with it. What's the shape now? Isn't it similar? Trigonal pyramidal it is, right? So I can simply write that this is also pyramidal. Both of these are the pyramidal in shape. And the question was, isostructural we need to identify. sp3 hybridization, isostructural, right answer. But we have to look at other option as well, right? Because in the question, if you are attempting, then you can move with the right answer. If you found the answer, you can move forward. But while you are preparing, you have to look at the other options as well. Why the other options are not correct? Because when you are preparing that way, then there would be the least chances of the error. Okay? Now CO2 and SO2, if I am talking, CO2 is a linear structure. This way. That's why its dipole moment is also 0. CO2. But SO2 is not of that type because a lone pair is also present on the sulfur atom. This way. Right? So this is bent molecule, right? Though it's planar, but not same as CO2. It's linear. Same ways H2O and XCF2. So H2O oxygen with the 2 lone pairs in water molecule, and bent molecule it is. sp3 hybridization and bent molecule this way. But XCF2 if you talk about xenon, 3 lone pairs and 2 fluorine atom are bonded this way. So both are not isostructural. It's linear, it's bent. Not same. Done? Now further we have this I3 minus and CO3 minus. Carbonate ion we have. Carbonate ion you can simply draw here that 3 oxygen atoms are bonded and 2 of them would have the negative charge. 1 oxygen is bonded with a double bond. This type of structure it has. CO3 2 minus carbonate ion. While this I3 minus is a linear structure. Linear structure it is. 3 iodine atoms are bonded together this way. The central one would have the lone pair this way because 1 electron is being gained. Right? So linear structure. So we can simply say the first option is the right answer, and since the very beginning I got the right answer here, the option 1, and it's very good about you all. Okay. Now I'm taking the next question, the question number 83. the number of angular and the radial nodes present in 4f orbital respectively are. So angular and the radial node we need to find out, and 4f orbital you have, right? So angular node is equal to L, while the radial nodes are n minus L minus 1, right? And total node, suppose the question is about total nodes, so total nodes is n minus L minus 1 plus L, so n minus 1 only, right? L value for f orbital 2, right? Not 2, 3. For s orbital it is 0, for p it is 1, for d it is 2, and for f it is 3, right? So 3 it would be. And n minus L minus 1 means 4 minus 3 minus 1 is 0. 3 and 0, 3 and 0 here, the option 2, right? And now the total number of nodes would be, total number of nodes, n minus 1, it means 4 minus 1 simply. 3 it would be, because sum of 3 plus 0 is 3 only, right? So this way we, yes beta, right Vikram. So I hope the questions those we discussed, the concept that we studied is clear to you all, isn't it? Okay, so here onwards what I just want to tell you all, keep practicing more and more questions, and those questions will definitely give you the confidence. Time abhi lag raha hai, lagaiye, but main target is just to complete the entire syllabus in a way that any time if a question is being asked, you can answer in the right manner. Okay, so yes Vikram. So my best wishes with all of you, and afterwards there would be definitely lunch time, and later we will be continued with this program of AIATS plus phase 2, and you will get more and more knowledge here onwards. Thank you so much.